Alright, let's do some easy exercises in polar coordinates. So, questions are convert from rectangular to polar. And, first question is, how about -3, 3? All right. So this is rectangular. I need to change it to polar. Let me first talk about the formulas here. For polar coordinates, I need to write it in terms of r comma theta, where r is square root of a squared plus b squared, and theta is tan inverse, let's use x and y, that's more clear. Tan inverse of y over x cos alpha, where this alpha is 0, 0, 180 here, 180 here. So these are the formulas. So I use the first formula to get the r. R is square root of -3 squared plus 3 squared. It's 9 plus 9, which is square root of 18. Now 18 has a square factor, which is 9. So it's 9 times 2, and 9 can come outside the square root as 3. It's 3 square root 2 is the distance from the origin. And then for the angles, of course we have this formula we can use, but sometimes, you know, it's better to just draw the thing, especially if the sizes are the same, then you know that this is something that has to do with 45 degrees, right? So it's actually easier just to draw it, -3 and 3. It's right here, right? So what's the angle from the positive x coordinate? 135 degrees. In terms of radians, what would that be? 135 degrees is 45 degrees, 3 of them, right? Because you have 1, 2, 3. And 45 is like a fourth of the 180, right? So it's pi over 4 times 3, which is 3 pi over 4. So the answer for this is 3 radical 2, 3 pi over 4. And you might say polar just to distinguish that it's not the rectangular one we're talking about. Okay? Yes?
You add 180.
Oh, okay, so let's try it this way too. Let's see. If we try to use the formula tangent inverse of y over x, and then because it's in the second quadrant, this is in the second quadrant, so according to this prescription here, we're supposed to add 180 degrees, right? So you add 180 degrees. Let's see, that's tangent inverse of -1 plus 180 degrees. And then tangent inverse of a minus can come outside. And by the way, this is true for sine and tangent, but not true for cosine, okay? So you have to be careful. Okay? When you take the cosine inverse, you can't take the minus outside. However, for tangent or sine, you can take the minus outside. Okay? That's because tangent and sine are what we call odd functions. Okay? Odd functions are functions whose properties allow that minus comes outside. Okay? All right. So that we know, and then at what angle does tangent become 1? 45 degrees. 45 degrees plus 180 degrees, so we get 135 degrees. So, of course, this formula does work. We can do it this way, but sometimes just drawing the graph is quicker. Okay. All right, let me do a second question. Let's see. What if we asked for number 2, say, let's say negative 2 radical 3, comma negative 2. Right-handed. How would we change this to? So same deal for r, square root of negative 2 radical 3 squared plus negative 2 squared. And that's 4 times 3, that's 12. Negative 2 squared, that's 4. 12 plus 4 is 16. So we get 4. So that's your r. So we're still at question number 2. Negative 2 radical 3, negative 2 rectangular. I want to change this to polar, and we just figured out that r is 4. That calculation is done over here. Now for the angle, well, if you try to use the tangent inverse thing, let's see, theta is tan inverse of negative 2 over negative 2 radical 3 plus alpha. And which quadrant is this in?
Third.
In the third, right? Because it's negative, you go left, and because this is negative, you go down. So you're in the third quadrant, and therefore this should be negative 180. I mean, it's not wrong to say plus 180. You just get coterminal angles. The two angles that you get, whether you subtract 180 or add 180, they will be coterminal, so it's not wrong. It's just that if you follow this convention, then your angles will be between negative 180 degrees to positive 180 degrees, which, by the way, is the preferred angles that most engineers want, because you tend to do this in your electrical engineering, and in that case you talk about how currents follow the voltage at what phase angle, and you usually want to say the current is ahead of the voltage if the angle is positive, if the angle is from between 0 to 180, and you want to say if the current is from negative 180 to 0, you say you say the current is following the voltage, stuff like that. So because of that, this is the usual convention taken by the engineers, but I mean, from a pure mathematical point of view, then whether you add 180 or subtract 180, it doesn't matter. Okay? All right, so you have tangent inverse of 1 over radical 3, and hopefully you remember that tangent inverse of this thing is 30 degrees. It's negative 150 degrees. Or since this is 5 times 30 degrees, and 30 degrees is pi over 6, it's negative 5 pi over 6. So the answer for this is 4 comma negative 5 pi over 6. I prefer radians over degrees, so I mean, sometimes I might ask for degrees, but usually you have to practice using radians. Now, if you kind of know that the ratio of 1 and radical 3 gives you something like 30 degrees or 60 degrees, again, maybe you don't have to do all this work. Maybe you can just draw the graph. Let's see how that works. -2 radical 3, so it's here, and -2 you go down. And which side is longer? Is this longer or that longer? The horizontal is longer, right? Because radical 3 is bigger than 1, so this is longer. So you see that this angle is 30 degrees, right? Oh, just a minute, something's not right. Oh, yeah, that's right, that's right. Yeah, this is right. Okay, so that's 30 degrees. So if this is 180 degrees, then what's the total angle? 210 degrees, right? Yeah. I was surprised for a moment because this is not the same as 150, but I realized it's negative 150. These two are coterminal angles, right? So if you view it like this, then the answer will be like 4 comma, this is 7 times 30 degrees, so it's 7 pi over 6. And either one will be considered as correct. Okay. So, this one, that one. Okay, so that's how you convert rectangular coordinates into color.